So here's the second practice problem video, and this is about uh, applications. And the one you'll get, the lab that you'll get, will also be about applications. So I think this is a good way to start thinking about how these functions, sine, things like that, can be used to model things in the real world. And things in the real world that repeat are prime candidates to be modeling by a sine or a cosine or something like that. Um, so one example is breathing. And we breathe in and we breathe out. Breathe in and breathe out. And that's a periodic behavior if you think about it. And it follows a certain pattern. So this model here, which is practice problem number 8, gives you a model, and it's supposed to mirror breathing. And I want to tell you a little bit about it. Then we're going to sort of look into it. So the sine function, we just talked about that. That tells us a little bit about, uh, that it's a repeating phenomenon, a periodic phenomenon. And so things like sine and cosine are good for that. We'll talk about why they have these particular numbers. Um, but what I want you to do is just, I want you to breathe in and breathe out a couple of times and think about what's going on. Now, this function is talking about, the V is the volume. It's sort of the amount of air that's coming in per second. In your breathing. So it's going to be a rate. It's going to be like how much we're breathing in and out over time, and it's in liters per second. And so let's just trust that stuff. And so if you think about breathing, you're breathing in a volume of air at a certain rate. If you're breathing in a liter of air, you're going to not do it all at once. Probably going to bring it in slowly. So that's going to be the. And what is that rate that you're breathing in? That you're taking in air and letting it out. When you take in air, that's going to be positive volume because you're growing your volume. So the rate's going to be positive. When you're breathing out, the rate's going to be negative because it's leaving your body. So these are the questions. But even before we do that, I want you to think about breathing and try to graph it. Try to graph your breathing and graph your breathing in terms of the volume that you're bringing in. So just think about that. Breathe in and breathe out. Do that a couple of times and just try to trace, draw a graph representing your breathing. And I'm going to do the same thing in a minute. But that moment when you're stopped breathing in before you've started to breathe out again, your rate there is 0 because everything is sort of at a standstill. And then you breathe out. So when you breathe in, that V is going to be positive. Then you pause your breath and breathe out. At that pause, you're going to be 0. That's what your volume, because it's just, everything's just staying there for a second. And then you breathe it out. Okay, so think about that. I'll give you a second to sort of try to graph your breathing. Okay, so here's how I'm going to think about it. This is going to be, I've just exhaled, so I'm about to inhale. And at that moment where I've just let all the breath out, I'm going to my volume is 0. Okay. Now I'm going to breathe in, so the volume's increasing. But I start. Remember, when I breathe in, I take in a little, then I take more, then I take more, then I take about as I take. I'm not going to take. I'm going to take more volume, but my rate's going to start slowing. And as I get near the end of the exhale cycle, I'm still taking in air, but just not as much. So the amount I'm bringing in is decreasing. So finally, at this point, I've completed inhaling. Okay. And here's sort of the peak of the inhale. Now I've got all that air in my lungs. I'm going to start letting it out. It doesn't go all at once. First, a little bit goes out, then more and more and more and more goes out. And then you kind of reach the peak of how much is going out. Then you're still letting air out, but just not as much because you're trying to get rid of all the remaining air in your lungs. And right here, I've finished the exhaltation. So here I've finished exhaling, and I'm about to inhale. Okay. So I'm back where I started. So think about that. Breathing in, now I'm breathing out. Okay. So that seems that would make sense. And I'm going to imagine that this took me about 2 seconds, and that this took me about 2 seconds. Again, I'm focusing on it and doing it slowly, so it's going to be a little bit longer. But so maybe I'm breathing for relaxation. Okay. So now this function is supposed to represent this graph, and let's go to Desmos and see if it does. I graphed the function, so here we go. Time to do a screen share. Okay. So here's the graph of that function, and it looks pretty close to what we drew. I'm going to just zoom in a little bit and just try to get one cycle in there. So we did this one cycle. That's exactly what I came up with. So this, as a model, this makes sense. The numbers, I don't really know what 1.75 liters would mean in terms of air. That's not my expertise, but I'm going to trust the people that made the model studied it, and they measured how much air and then how much air you blow out and stuff like that. So let's assume like maybe into a balloon. So I'm just going to look at the values of the graph. I think it's good to do a table. So, oops, sorry, it's not what I meant to do. I meant to hit this one. Oh, okay, good. And I'm going to add a table, and then we're just going to do some values. So it's 0. Now we're going to look, I'm going to make this, I have to write this whole thing here. So I'm going to change this to t. I think it allows me to do t. Yeah, okay, good. Again, that's what we said. Okay, then I'm going to see it at a half second. Okay, this means that I'm bringing in some air at a full second. That's when I brought in as much air as not as much as I'm going to bring, but the rate is quicker. And now I'm still bringing in air at 1.5 seconds, but I'm not bringing in as much. And then at 2, I can't bring in any more, so I'm about to exhale. Then at 2.5, I'm exhaling. So again, air is coming out. That's what the minus means. At 3 seconds, I've kind of reached that, the volume of exhale, the rate of exhale is about at its peak. I'm still going to be exhaling, but I'm not letting as much air out as I did before. And finally, there's no more air. And the thing just repeats. And you see here here, let me just turn this off. I don't know, something went, okay, got it. I got to fix this function. So let's take that off for a second. Okay, so that's what the function is telling me. So, oops, I think I need that function. So something is going on in the graph. So here, let me just, I'm going to call it v of x because it's something about the way I was naming it didn't like. So let me put this back in. Okay, and let me turn that off. Okay, so here's what those points, and if we connect it into a graph, WebAssign will kind of guess at what the graph should be. And so let's see. No, it's not going to. Yeah, here it is. Okay. Now it's going to guess at what the graph could be, and so it makes a pretty good guess. Now let's see how the guess compares with the actual, and it's going to be pretty much the same. You can see it overlays it. So my point of going through all this stuff was to try to give you a sense of what the model did, that our intuition, just sort of graphing breathing without looking at any math, we came up with a curve that looked like this, and that this is the model that they came up. So the model is what they like to call reasonable. It makes sense. It matches our intuition. Okay, so I'm going to stop the share. We'll come back to this. Okay, so that's where we are. So now we have some questions. The time of one breathing cycle. So as on the practice problem, I say think about it as a period. So this is going to be that letter B. That's going to be the amplitude A. So the time of one cycle, A is going to be the period. And we're looking at sine of B. When we have sine of BT, the period is 2 pi over B. So B is going to be equal to pi over 2. So the period is going to be equal to 2 pi over 2. We have to invert and multiply. So we invert the fraction, the bottom, those cancel, and we get 4. So a period is 4 seconds. How many in a minute? Well, 4 seconds per cycle, 60 seconds in a minute. So 60 divided by 4, 15 cycles in 60 seconds. Okay. And again, we already looked at the graph. We'll look at it one more time real quickly. I wanted you to do it with Desmos. And there's a picture of the graph. Okie doke. Okay. That's it for this problem, and we're going to do the next problem, which is about a Ferris wheel. So before I'm going to do the same kind of thing, and before I introduce the Ferris wheel problem, I'm going to tell you about this Ferris wheel, and then we want to graph it. Okay.